Hello and welcome to my Triple E 120 Lab 3 recording. I'm here to display my circuits and GTK wave displays. All right, starting out with the 4-bit reg circuit. If I have D as my input, I have Q as my output. Let's say if I want to make my D, the input is 3. Um, so right now, nothing's really showing up. However, if I enable and then I clock it, it then automatically puts it in the output for Q. So it's pretty neat. It works with 4 flip-flops and using a 4-bit multiplexer. This means that it works for maximum 4-bit binary. So from numbers 0 to 15, it's essentially the entire hexadecimal. All right, moving on. We have the GTK wave display of the circuit. So as we can see, here's the clock, the reset, enable. We have D, Q, and this is the 4-bit reg circuit. All right, so let's move on to our next circuit. So our next circuit is going to be the 4-bit up counter. So over here, the 4-bit up counter works as essentially a counter for 4-bit. So essentially, for 4-bit binary is where it's able to operate at. So let's say if it starts at a 0 right now, let's say I have an enable over here. This enable essentially allows me to clock. So every time I clock it, the counter will move up by 1. However, I can reset and then it essentially will reset the counter to 0. If I don't enable the counter won't work. So the enable has to be active. Moving on, here is the 4-bit RAM. So here is my 4-bit RAM. So we have a data input. We are able to write, and then we're able to clock. So essentially, if I have my data input as 5, and let's make the address as 0. So right now, it shows the data output as 3. However, if we were to write and clock it, then it will write the data output as being 5 as opposed to 3. So it's pretty nifty because then we can record the output over here using the program RAM. All right, moving on. Moving on, we have a brainless central processing unit. So essentially, this brainless central processing unit is capable of doing multiple things. It's capable of doing multiple functions. Um, it can also, just like what we recently discussed before with the program RAM, it's also able to essentially take an input, for example, if we make the input 5, and it's able to write and essentially if I when I write and clock it, and then it will read and essentially it will output it to data bus as 5. So I'm able to essentially take an input and essentially write and clock it within program RAM over here to the data bus. So over here we have things we can invert, we can do arithmetic, which is addition. So as we can see, 0 plus 5 is 5. So the ALU essentially does the arithmetic for us. This ALU is essentially the ALU circuit that I have done for my past laboratory. This 4-bit mux is also from like the past laboratory. All of this is in 4-bit. So all the numbers that can go in through here are from 0 to 15, essentially hexadecimal. So this is a brainless processing unit for a 4-bit. It's able to do multiple things, able to read and record, it's able to add, it's able to invert. So then like you can do subtraction and addition with this. Essentially, also able to pass, essentially, you're also able to load and you're also able to reset as well. So let's say I can reset and then essentially I can reset this data bus. So yeah, here is the GTK wave for this one. So as we can see, um there are multiple wires and there's multiple inputs and outputs for this one. So we have the clock, the reset, the input, the address bus, inverter, and then we have all the ALU functions over here. Then we have the loading, and then the writing and reading, accumulators, all of that. So in order to test out my circuit, I created a bunch of test cases, which I will show. So essentially, I created a brainless ext write.v. I created a brainless int write.v, a brainless alu.v. So essentially, using these I made sure to use these like, additional test cases. And I also made sure to test it on GTK Wave. It took a lot of tries for me to get the test cases to work properly within this. However, I was able to like ref infer whether they worked well or not due to the fact that I could get like a GTK Wave output out of these. So here is the remaining GTK wave. So this is the GTK wave for the brainless EXT. So over here, as we can see, it's the same inputs as like the brainless stem that we looked at earlier. However, as we can see, the why is the difference? It's the difference inputs that I put for the test cases, as we can see here. The same thing is also for the brainless int. This is a different set of test cases that I used using the brainless CPU's circuitry that as can see me over here on the digital. Here's my third case. Here is the brainless ALU, and this is mainly for like the ALU functions, for example, like the addition, the inversion, arithmetic, etc. All of the all of like the ALU inputs that and I had to actually refer back to the lab too to see how the ALU circuit works in order to make sure that I'm able to like, correctly like figure out the logic for the ALU part. All right. So this is the end of my presentation. I hope you were able to infer my understanding on the lab circuitry involved. Thank you so much, and make sure to have a good rest of your day.